Chapter 6 is environmental considerations. This whole chapter talks about different stresses that the environment can put on the athlete. Some of the health concerns here is we got the hyperthermia, which is the heat that we talked about, the heat stress. We got hypothermia, which is the opposite spectrum, the cold. Altitude, exposure to the sun, lightning storms, air pollution, which really applies to the valley. And then I'll explain what this is when we get to it so it makes sense. I'm sure some of you haven't heard of this kind of dysrhythmia that takes place. So I'll go over that one. Okay, hyperthermia we talked about extensively in class. So it's just on here for you to go over. Talks about heat stress. And you can look at the PowerPoints to refresh yourself. So we'll just skim through this. Okay. Talked about the different little heat exchanges. That's on there to remind you. I'm scrolling through. Let's see. Heat illness. Talk about some fluid replacement. Let's get to something that we haven't gone over. The heat index. I went ahead and left that on there for you. This is the one that I've used rather than a sling blade or the wet bulb that we use. Talked about the different heat illnesses, so I left those on there for you to refer back to. We didn't talk about this in class, but I left this on here. Exertional hypo. Remember, hypo's too little. Hyponatremia. This is where it has to deal with the sodium intake, and this is where it's abnormally low concentration of sodium in the blood. This is just a review over. Oh, here's some guidelines for athletes who intentionally lose weight. Most of the time I hear they just stop eating, and that's not good to do, right? You need that nutrition. Provides the necessary electrolytes to stay hydrated. Especially if they're not eating, they're not drinking. So, then we talked about this in class about working out and keep working out until you lose that weight when it's really all you're doing is losing water weight. Okay. So here's hypothermia. This is cold weather. Now I know the activity it doesn't really get that cold here, okay, but if you're in snow country, this may apply to you more. So even when you start being active, your metabolism speeds up, right? And so it starts producing heat. And this is how we start sweating, okay? And then that's how we cool our body down. It's when the sweat evaporates, right? So when it's too cold outside, there's an effect here. Okay, that's not going to allow for appropriate heating and cooling. It's going to be impacted. I don't know if anybody's been in snow country, but say it's 40 degrees, but the wind chill is negative 20. Okay, that plays an effect. That doesn't so much here in the valley. So I left this on here, again, just for your information in case you end up going in cold country or get into skiing or such, you know. This goes over the heat loss. 65% of the body heat is lost through radiation. Okay, we talked about the head and neck being a big contributor to that. 20% is lost through evaporation of your sweat, right? 2/3 is through the skin, 1/3 is through respiration. Don't forget your breath has moisture in it, right? You blow on a mirror and it's moisture, okay? So 1/3 of that evaporation is through your breath. So this is where the problem arises. Okay, when heat loss exceeds heat production generated by metabolism, is we get this drop in core temperature, which stimulates shivering, and then everybody knows when you're cold and you start shaking, you start shivering. Okay, but that stops after the temp goes below 85 to 90 degrees Fahrenheit. See right here beneath that, death is imminent when temp falls below 77 to 85 degrees Fahrenheit. Okay, it's really important to make sure you're aware of that surroundings, whether it's too hot or whether it's too cold. Be aware of the hyperthermia and hypothermia. Both have pretty serious effects to each extreme, to each end of the spectrum. So some common cold injuries we have. Let's go over frost nip. Okay, that involves places with an end circulation, meaning ears, nose, your chin, your fingers, your toes. Those always get the coldest. Okay, and that's usually where this occurs. As I would say, occurs with high wind and or severe cold. Okay, skin appears firm with cold, painless areas that may peel and blister. It takes about 24 to 72 hours. You'll have these. The way you want to treat it is with firm pressure, blowing warm air, like when you blow hot air into your hands to warm up your hands, or sticking your hands in your armpits, right? And don't rub it. Don't sit there and rub and cause that friction, okay? Nice, solid pressure. And then frostbite, we've all heard of frostbite. Well, this next one I'm going to show you a picture of what some frostbite looks like. Okay. This one here. So this is more of a superficial frostbite, right? If you go back a slide, it talks about superficial frostbite involves only skin and subcutaneous tissue. So, like I said, superficial. And then you have that deep frostbite, which indicates frozen skin requiring hospitalization. See how that turned black? Look at that one. Oof. Definitely need to go to the hospital for those fingers. Okay, I left this on here. There's other things in the chapter that you should kind of look over, but I left this on here because I know we test every single athlete that comes in for a sickle cell trait. Predominantly 8 to 10% of African Americans have sickle cell. And most of the time when you have the trait, it's benign, meaning it doesn't react. Okay, and what it is an abnormality in your red blood cell. So most time you see a nice, if you've ever seen a red blood cell, it looks like a donut with kind of impression in the center. Well, when the sickle trait, if you have that sickle cell trait, when it reacts, it starts to become moon-shaped, like crescent-shaped. So then it ends up blocking and getting stuck and causing all kinds of problems in your blood system. So when the hemoglobin is deoxygenated, the cells, because they change shape, they start clumping together, causing a blockage. So that's how this sickling, once you start to sickle, once you start to respond and react, like I said, most time it's benign, but if you do happen to sickle, this reaction takes place. So the blood cells, they start changing shape and they start clumping together. And then those cells will start to destroy, okay? It causes enlarged spleen and could rupture at high altitudes. So this is something we want to make sure we're aware with our athletes of who has it. So that way, when they're exercising or exerting themselves, that's when sickling usually occurs. We're prepared and ready, and we can handle that situation. Okay, overexposure to sun. This is good for the valley. Okay, wear sunscreen. That's why I put this on here. You can get melanoma, cancer. That's cancer on your skin. Melanoma changes the color of your skin. That's why you tan. So you definitely need to either wear hats, protect your face, wear lots of sunscreen, and sunscreen works when you reapply it. Okay? And then we're going to mention lightning safety real quick, because what I want to go over is the flash to bang theory. That's how you tell how far the lightning is. Not too often do we get lightning storms here, but if you're in the Midwest, they definitely get some serious lightning storms. And that is... Here you go. So the flash to bang method estimates the distance away for the storm. From the time the lightning is sighted to the clap of the thunder count, divide by 5 to calculate the number of miles away. So when you see the lightning, you start counting, right? 1, 2, 3. Okay, so say we get up to 30. Well, you're going to divide that 30 by 5. So what is that? Okay, count at 15 seconds, everyone should leave the field. So when you count 15 seconds, you divide by 5, it's 3 away. That means you need to leave because the lightning could possibly strike. Especially if you're in metal stands, whatever. Get inside, get grounded. So that's how you do the flash to bang theory. Okay, you count in seconds, time to see the lightning, and then your final count when you hear the thunder. Then you divide that by 5, and that's how many miles away it is. Okay. And there's an NATA recommendation that 30 minutes, after 30 minutes, you can return to the field following the last clap of thunder or lightning strike. So you have to wait 30 more minutes until you can actually go back and continue your either practicing or games. Oh, in case this is a fun fact, most time people assume it's the lightning up in the sky that strikes down. It's the return stroke. So as the lightning comes down, it gets into the earth and it comes straight back up to go back up, and that's the one that usually gets people. Okay. This is a lightning detector. We don't have those because we don't get lightning too much, but I almost guarantee the Midwest does. And then left air pollution in here for you guys. We talked about the warning signs and the colors, or how the high schools judge air quality depending on whether or not you can practice. All right, so that's a really fast overview of this chapter. So I'll see you in class.